Our next lesson in Chapter 4 is 4.7, Complete the Square. In this lesson, we'll take an equation for a quadratic function in standard form and use the complete the square method to convert to vertex form. The purpose of complete the square is simply used to convert from one form to the other. You'll start with an equation for a quadratic function in standard form and we'll convert it to vertex form. We can find things like a maximum or a minimum value of a quadratic function using this method, and it's also useful in solving for x-intercepts. The complete the square process is pretty intense. Notice we have a lot of steps to follow. It says given ax squared plus bx plus c equals 0, the first thing you want to do is move your c value to the other side, and you'll either do that simply by adding or subtracting. One thing to note, if your a value isn't 1, we have to factor a out of both terms. Even if a doesn't go into b, we end up with a fraction, and we'll have those today. Once you have step 1 complete, take half of whatever, there we go, of whatever your b value is. Once you get that number, you're going to square it. So we do 2 steps in step 2. Take that squared answer and simply add it to both sides of your equation. Then what you're going to want to do is factor. And what's helpful to recognize is you're going to use your answer in the first part of step 2 to help you with that. Once you have your answer factored, write as a perfect binomial square. Perfect square binomial, sorry. And that's where we sometimes write like x plus a number squared. That's what it means to be a perfect square binomial. What you'll do then is move the new c that you've calculated, because you'll have to combine some like terms, back over to the binomial side. And then your answer will, voila, be in vertex form. So again, it'll go from what it looked like in standard form in the blue to the vertex form in the bottom in blue. And what we'll do today is just a variety of methods to work with this, and then when we finish our notes in class, we'll do the solving part of it. So let's see how this works. It says find the value of c that makes the quadratic expression a perfect square. Then write the expression as a perfect square. For this, we're going to use just steps 1 through 5. We won't have to use all of the steps. Notice we have the x squared term and the bx term only. We don't even have a c to start with on this one. So actually for this part, we'll go right to step 2. Take half of that b term, or b coefficient. Half of 16 is 8. And then it's said to square that number. 8 squared equals 64. And that's what you do to find c. It's really that simple. C would be 64. Now when we add that on, we get x squared plus 16x plus 64. And then we factor. What are two numbers that multiply to get positive 64 and add to get 16? Lots of factors of 64, but the pair that would work for us are 8 and 8, the same number. And they're both going to be positive. That way when we add them, we get positive 16. Now remember, in those steps, it says your answer in the first part of step 2 is helpful. Notice when we took half of 16, we got 8, and that was the answer for the factored form. And then last but not least, in step 5, write as a perfect square binomial. If you have 2 of the parentheses that are the same, we've seen this in our answer keys for the previous lessons. We can write that as x plus 8 squared, and that is a perfect square binomial. Let's try the next one. X squared minus 4x. We have our quadratic term and our bx term, but we're trying to figure out the constant of c that makes it a perfect square. In this example, b is negative 4. If we take half of negative 4, we get negative 2. And if you square negative 2, be careful on this one, negative 2 squared is positive 4. That's what the c value equals. Add that to the top, x squared minus 4x plus 4, and we have a perfect square trinomial. To make it a perfect square binomial, we factor. So we'll use two parentheses. What are two numbers that multiply to get positive 4, but add to get negative 4? That would be negative 2 and negative 2. Negative 2 times 2 is positive 4, but negative 2 plus negative 2 would be negative 4 in the middle. And remember, that was our answer that we got up here in the first part of step 2. Because they're the same, we can write that as a perfect square binomial, x minus 2 squared. All the work that we do today is going to be related to write our equations or our process in that form. And then, of course, we come to one that has a coefficient in front of the x squared. 5x squared plus 45. Oop, there should be an x right there. Sorry, that should be an x. Please make sure to add that in, otherwise it doesn't really work. What makes this interesting is we have that a value of 5. Remember up above in step 1, if it says if a doesn't equal 1, we have to factor a out of both terms. And this is no matter what, everybody. Even if it makes b a fraction, this is still what we have to do. Also notice we're not factoring out 5x. We're just factoring out the 5. And it looks like this. 5 on the outside, and we'd have x squared plus 9x on the inside. And now this kind of looks like a and b. With that x squared and the 9x, our b value changed from 45 to 9. And if we take half of 9, that would be 9 halves. We're not going to put it in decimal form. We're going to leave it as an improper fraction. Whoops, not 9 fourths. Let's make that 9 halves. And then we have to square that. If we square 9 halves, we're just going to square the top number and the bottom number. That's all it is. So 81 on top over 4 on the bottom. Here's where it gets a little weird. 81 fourths isn't our C value. We have to actually take the 5 and multiply it by 81 fourths. So 5 times 81 fourths, I have to put 5 over 1 and literally multiply straight across. 5 times 81 is 405. Therefore, our C value that makes us a perfect square binomial is 405 fourths. However, we take the 81 fourths and add it to the inside. So watch how we finish this part of the problem. Still keep that 5 on the outside, and we have x squared plus 9x, and then we add 81 fourths. To factor, what are two numbers, and this is weird too, what are two numbers that multiply to get positive 81 fourths, but add to get 9x in the middle? And that's where this number comes in. If you remember that that step always gives you your factor, we know that this will split apart into x and x plus and then 9 halves for both parentheses. It's the same thing. Remember that 5 out in front? Our final step is to write it as a perfect square binomial. So x plus 9 halves squared. Now this process is going to help us determine how to convert to vertex form from standard form, and we can use this as an alternate option for finding x-intercepts. When asked to convert from standard to vertex form and decide if your function has a maximum or minimum, we follow these rules on the left. If a is greater than 0, meaning it's a positive number, we would determine that the function has a minimum, and that would be at the vertex. If a is less than 0, meaning that the a coefficient is negative, then the function has a maximum. The vertex would be at the top. So minimum would be like the lowest point, maximum would be the highest point. As we complete the square on the right-hand side, make sure to write small in order to get everything to fit. All right, convert each quadratic function from standard to vertex form. Then decide if the function has a maximum or a minimum. Our first example, y equals x squared plus 7x plus 4. Notice here, right in front of the x squared, a equals 1, and that's positive, which means we're going to have a minimum. Now we'll come back to that at the end. Up above it says, given that ax squared plus bx plus c equals 0, the first thing you want to do is take the y value and just plug in 0 in its place. So 0 equals x squared plus 7x plus 4. When we write our final answer, we're going to bring y back, but for now we're just going to mark it as 0. And then it says move c to the other side. We'll do that by subtracting 4. Because a equals 1, we don't have to factor it out, which means we can go right to step 2, which is going to be crazy because we have b as an odd number. So if we take half of 7, kind of like our example up above, we end up with a fraction for this step, 7 halves. So I'm going to put a little star by that because we're going to come back to that when we factor. But then we have to square that number. So we're going to square the 7 halves, which just means we square the top and the bottom. That would give us 49 fourths. Step 3, add that to each side. So what that means is we're going to take negative 4 plus 49 fourths on the left, and then set that equal to x squared plus 7x plus 49 fourths on the right. That's step 3. Pretty simple. Now, on that left-hand side, in order to add that integer with the fraction, let's put negative 4 over 1 and just get a common denominator. If we multiply the top and bottom by 4, we would get negative 16 fourths plus 49 fourths. So we'll simplify that in the next step. On the right, we're supposed to factor. Really, x squared plus 7x plus 49 fourths. We're supposed to factor that. But remember, that's where this step right here helps us out. What are two numbers that multiply to get 49 fourths but add to get 7 in the middle? 7 halves and 7 halves. That gives us x plus 7 halves times x plus 7 halves. Kind of a nice little deal if you remember that step. On the left-hand side, negative 16 fourths plus 49 fourths is 33 fourths. Oh, that's a 3 right there. There we go. On the right, we can write this out as a perfect square binomial, since it's the exact same, like so. And then it says in step 6, move the new c value back to the other side. So 33 fourths, we'll have to subtract that over to the other side. I can't get my 3's to write for some reason. There we go. So then we want to write our equation in vertex form. I'm going to go back to the y equals here, put a little star just to recognize that. We're not setting it equal to 0. It'll be y equals x plus 7 halves squared minus 33 fourths. And there's your equation in vertex form. Remember the second part though, it says determine if this has a maximum or a minimum. Well, up above, we already said it was a minimum. So I'm going to write minimum at, and then the nice thing about this is the answer is always just the y coordinate of the vertex. So the minimum is simply at negative 33 fourths. And that's the second part to our answer. Hopefully you have one more example left in you. We want to get through this one before we do the problems that are on the back. So we have f of x this time equals negative 2x squared minus 12x plus 19. Here notice our a value is negative 2. Since that's less than 0, that's going to indicate we have a maximum. So our vertex is going to be at the top of our graph. All right, let's take that f of x, and for now, we'll just set it equal to 0. Negative 2x squared minus 12x plus 19, and then move 19 over. The steps individually are pretty easy to work through. It's just kind of remembering how to do them all. Now, in step 1, remember it says move c over, and if a isn't 1, we have to factor a out. Notice a is negative 2. So that's going to be interesting. If we factor out that negative 2 on the right-hand side, we would get negative 2, and then x squared plus 6x. Make sure you have plus 6x right there. Because negative 2 goes into negative 12, positive 6x times, okay? All right. Then what we're going to do is take half of this b value, half of 6, and that's 3. And that's the number we'll use later, so at least it isn't a fraction this time. And when we square 3, we're going to get 9. Okay, here's another goofy step. So when we add that to each side in step 3, we have negative 19, and I'm going to put plus, and I'm just going to put a little blank right there, and I'll show you why in just a moment. Remember, we have a negative 2 on the outside, and then x squared plus 6x, and then I'm going to add 9 on the inside. Whoops, I want that in green. Hang on. But then I'm going to put the 9 in purple. There we go. We added 9 in the parenthesis, and that's what completes the square. But technically, negative 2 times 9 is actually adding negative 18. So we're going to say actually added negative 18 because of the negative 2 out in front. So guess what, everybody? That's what goes on the other side. So you think that's going to be a tricky thing to remember? It absolutely will be. That being said, from here on out, we should be pretty straightforward. Negative 19 plus negative 18 would be negative 37 on the left. On the right, keep that negative 2 on the outside, and let's factor x squared plus 6x plus 9. What are two numbers that multiply to get 9 but add to get 6 in the middle? You've got it, 3 and 3. This should always create that perfect square binomial. And then we just write it as a perfect square, as x plus 3 squared. Move your new c over, so we'll move negative 37 over simply by adding it to the outside. To write our answer in vertex form, remember the original problem was f of x equals negative 2 times x plus 3 squared plus 37. This is our answer in vertex form. Last but not least, we know we have a maximum, and it's always just at your k value. This means we have a maximum at 37. And there is the first part of our notes for 4.7.